Hello, we are eXpense, a business expense management solution. My name is Brian Seiske, and with me is my team Duncan Hill, Sean Moore, Reece Schilling, and Megan Ritchie. So the problem. Business expenses have always been a problem and still are today. Filling out expense reports is tedious, it's wasteful, and quite frankly, archaic. We're in the 21st century. We can move forward, we can bring it to the digital age. So that's what we're trying to do.
So that being the problem, we have a solution. And the solution was actually brought forward by my father, who approached us to build this application, which we designed to be an iOS application on the end user side, and then we also have a web-based administrative site for receiving the reports.
Now, in order to do this, we're going to be utilizing a series of technologies. For example, we'll be utilizing the Microsoft Azure platform to integrate with our client's existing platform, along with Swift, Bootstrap, and some of these other technologies.
Some of our motivations behind our solution were to have a user experience that's time-saving, as well as simplistic, and to go environmentally friendly and paperless.
And with the notion of creating a scalable application, we wanted to make a secure and travel-friendly application for the business professional on the go.
So the idea behind this application and how we're going to be implementing it is we're going to be developing this in a Scrum methodology. So we'll have our set series of tasks that we'll be implementing. And at the same time, we'll be using a series of tools that'll kind of help set the standard for what we're going to be developing. For example, we'll be using Trello for, again, the Scrum development. We'll be using Xcode for the actual iOS application development, and SQL Server Management Studio for our data management needs. Now, along with this, the high-level picture of our application that we'll be developing is really multi-fronted. So on the scenario with the iPhone side, like we've already mentioned, it'll be handling the expense reports, it'll be developing the reports that'll be sent off to our web service. Now, the web service really acts as our primary focal point. The web service is built on the Azure platform. We'll be developing it so that it can handle all of the data processing. It'll be handling the authentication. It'll be handling all of the central activities core to the application. And then, as Ree mentioned, we'll be developing also an admin site that'll be built, again, on Microsoft's Azure technologies. And in this process, we'll be able to build a user interface over the top of that that's hosted on Azure and can communicate directly with the web service. Now, what's tying all of these architectural pieces together, again with Azure, is a key thing, though, that Azure offers that accelerates this process. It's the idea of a mobile service. And what this allows us to do is, for example, with the iPhone application, the communication between the web service and the iPhone is generally something that you have to define an explicit protocol or use existing protocols for. Well, we're able to go one step further. We do have an existing protocol for communicating with Azure Web Services provided by Microsoft, but more so, it's already set up to handle their existing technologies. So while we're developing in two separate technology stacks, it's almost as if they're unified in a single dimension. Now, that iPhone application, that web service, is built on top of another Microsoft technology known as a web API. And what this allows us to do is, on the exact same code stack, build a web service that can communicate over with the admin site, which shares no similarities in terms of implementation as with the iPhone stack. And behind everything of those that I just mentioned is the idea of our SQL Server data storage and our blob storage. And those are our core companions to the web service in terms of storing our data for our clients.
Cool. So I'm going to take a minute to go over the use case scenarios for our system. This is our use case diagram. It really defines the relationship between the end application user and the administrator. So the end user who's using the iPhone application will really, the core functions there would be creating a new one-time expense or a trip, and that they will compile those reports and send them to the administrator, who will receive them from the web service on the administrative site. So I'm going to start on the iOS side of things. The first main function that the end user can really do is a one-time expense. Now think of a one-time expense as a single transaction that an employee may make on the company dime. So if an employee takes a client out to lunch, for example, that would be a good example of a one-time expense that they may want to send back to the administrator. The second function would be a trip. So if the end user is going on a business trip or some sort of thing, they're going to be making a lot of singular transactions that are related to each other, and those are all compiled underneath the header of a trip. So if I was to take a business trip to Dallas, for example, I would need travel expenses, lodging expenses, food expenses, that sort of thing, and they all compile into one report that gets sent back to the administrator. This is a flowchart of the iOS side of things. I mentioned the two on the far right, the adding a new trip and adding a new one-time expense. I want to mention the other two functions. Obviously, we have our settings where you can change account information, but we can also go back and view existing expenses. So here you can go back and maybe add an additional expense to a trip that may not be completed yet, or go back and edit an existing expense that may need some changes, and you can go ahead and resend those again from there. So that's really the iOS side of things, and then I'm going to go speak a minute about the admin center. So the admin website really has three types of management to it. You can manage reporting, so receiving those reports, as well as making any edits or downloading those to your computer so that you can use them for administrative purposes. The second type of management would be user management, adding, deleting users, and maybe assigning administrative capabilities to a specific user. And finally, we have access management, where you can restrict access based on domain, so maybe restricting access to the system based off of your company's email domain. I'm going to pass it off to, I think Sean's going to talk about design.
Well, actually, I'm going to talk about design and tech specs here. So the idea of making a good app is that, first of all, it has to perform well. If your app is not responsive, and if it doesn't perform any function in an efficient time, it's not going to be worthwhile no matter how pretty it looks. So here's some notes we have to keep in mind when we're implementing this application. The first thing is file I/O, because we're going to be working with a lot of files, obviously, for expenses, as well as images of all the receipts. So there are certain things we have to keep in mind with file I/O. According to Apple's development standards for performance, files can really bottleneck your application. On their website, it says that for every file I/O operation, you can run about 1 million instructions on the CPU. So we don't want to be opening and closing files all the time. Whenever we can keep one open, we want to. Also, I think to help with this, we want to use iOS's caching system, as well as NSCache or NSDictionary, depending on the situation, and maybe have a caching system on our back end as well. Also, when you're reading from files, it's recommended that it's done in sequential order. You're not jumping around a file. It makes the operations a lot smoother. There are some other basic things, like with frameworks, only import what you need, not what you don't need. It just creates unused code, makes your application less optimal. And then memory, we want to do things like utilize constants in Swift, only use whatever memory is necessary. And then last thing is background events. So Apple has this concept of perceived performance, which is that maybe your application doesn't optimally perform as much as you'd like, but you can use things like background events so the user isn't aware to the otherwise. While things are running in the background, the user still gets a fully responsive app. Okay, now on the design side. With iOS 8, there are some new standards of design to make sure our application is up to the latest and greatest standards. So first are things like borderless buttons. So as you can see on the left is one of the old style buttons in iOS. On the right is the new one. There's no border. It's cleaner. It's more minimalist. It makes things simpler for the user. The second is the idea of transparency. So Apple recently moved to a layered architecture where as you move closer to things or move into something, you move up a layer. Now they talk about wanting to keep things transparent so the user feels like they can still access the app. So on the right here you have an example of what not to do, where the layer is not transparent, versus on the left where you can somewhat see the background and transparency. And then two other features we have that we want to make sure is interaction minimization. That means getting rid of things like splash screens and also using whatever we can find in the user's iPhone to make them fill out as little as possible. We don't want to have them doing frivolous things. We want them to just jump in and be able to start using the application. And then the last thing is proper weights and standards. So the diagram here again is provided by Apple's developer site. Things at the top left are deemed most important, and then as you move down and to the right, they're deemed less important on the screen. So laying things out according to their weight and function will be very important. Last thing, if we're going to use things like a control, they have standards like a control needs to be at least 44 points. So keeping those things in mind, keeping a friendly user environment so that it's an intuitive design is what we're striving for.
We will be implementing our mobile application in Apple's brand new programming language called Swift. This will be implemented in Xcode, the latest and greatest version, which is currently 6.1.1. This application will be a combination of table view controllers as well as UI views, which is composed of UI text fields and UI picker views. This framework that we're going to be using behind this mobile application to power it is MVC, or Model View Controller. This model view controller allows us to break up the data from the actual view or the objects that the user sees, and it also allows us to change the data without affecting the views on the side of the mobile application. So we will also be using auto layout constraints in order to make a similar experience across all devices and orientations of the device. This allows us to go from an iPhone 4S to an iPhone 6 Plus without the user having to adjust to different devices or orientations. So we're also going to have a table view controller that is composed of dates or timestamps that are made within the form. This table view controller with the data is going to be sorted by the timestamp that is created on the time of the expense.
So now we're going to go to the back end side of things, and what I really want to start off with is the database. From our ERD, you can tell pretty fast that it's denormalized. We made this decision for multiple reasons. The first, it makes the complexity a little less, but more importantly, when we query the database for our data, it's going to make faster response times because we mainly will have less joins between tables. No.
Okay.
As well, the next thing I want to talk about with the ERD is that in the one-time expense table, that photo attribute, it's not actually going to be where we're storing the photo. We are going to be using a link to our blob storage so that way we can get rid of the binary file in the database to keep it smaller. With that blob storage, we're actually only storing photos in there. We've talked all about making these reports and keeping all the data, but like, where have we compiled these reports? It's actually going to be a part of the web admin site where it'll be a web service. It'll be a web service where the admin will go in, they'll click, I want to make this report, and it will all be generated right there. And then the user will be in charge of downloading it to their computer to save it. If for some reason the user forgets to save it or loses it, they can always go back and recompile it.
Good.
This is just a basic timeline of what we plan to do for next semester's implementation. Currently there are no end dates because we still need to make that decision next semester when we know more of everyone's schedules.
This is just a quote that I thought summed up our projects from a local Columbia native, Sam Walton. It really just kind of exemplifies the importance of our application. I think that's pretty well it. Thank you.